Today I'm here to talk about high throughput XMPP based router and why would you need it? It's more like a story. This is an embryonary project I'm conducting with Manuel right here. Um, so on background, I'm Thiago, I'm from Brazil. I'm a software architect, mainly working with some protocols that you might know. XMPP, Jingle, SIP, 2GPP, Jingle Nodes, and WebRTC. On the past years, um, I can tell that I was mainly involved with Jingle Nodes from the beginning and also Jingle. I can claim the graphic designer for the Jingle logo. I'm very bad, but still there's something published. Um, how many of you guys here are familiar with 3GPP and old telco? Okay, sorry for you guys, we're on the same boat. So it's nice. So I started on SS7 and then I moved to SIP and then I discovered XMPP, and so since there I'm trying to use it as much as possible. That simplifies my life. It's not a personal preference, but also easier to get developers, easy to understand, easy to debug, and extensible. So nowadays communication is not only about calls anymore, right? We're not at Graham Bell era anymore, a little bit ahead. So WebRTC proves us. There are the guys with rich communication, whiteboard, screaming, let's say voice detection, etc. So let's talk about event buses. This is the picture that you usually download on the internet that describes an event bus. It sounds very simple, like we have connectors, very organized, consumers, producers. It's brilliant. But then when you join a project or when you go to a company, that's more or less what it looks like at the end. And that's simplified version of it. Obviously, when you join a project, not always you can build it from scratch. You need to inherit stuff as well. So yes, so how you can simplify that equation in order to have a running product? Well, you can see there Kafka, so that's the red spot there. I will try to explain why is a red spot and was a red spot for us. It's a great application, so don't be scared to use it, but in our case on real time, it did not suit our needs. So let's talk about that. We have some standard event buses on the market. We have Kafka, we have RabbitMQ, we have ZeroMQ, and others. Those are the most frequent use. From the documentation, the ones that had the nicest pictures were Kafka, so we just used it. It was sound very simple, so we got Kafka. And then we're dealing with real time, as I mentioned. It's everything about communication, it's about events, it's about commands that are not necessarily persisted. Obviously, I'm not talking about CDRs here that has to be persisted, otherwise we cannot charge our customers. But basically, we start having problems when deploying Kafka for an event-based bus. We noticed that persistence was never used. So Kafka has this great feature that you can rewind on the window and replay the events that's embedded into the system. That's great, but we never used it in almost 2 years of project. It's a pity, but okay. We had this painful load balancing resize. If you need to have more nodes, you have to increase, you need to go to Zookeeper. If you try to do it manually, automatically, not always works. You might have reconnections, frequent reconnections, problems with throughput. Biggest problem, congestion. This was like, at some point we felt like a traffic jam in Mexico City or in Sao Paulo, you know, during this project, because it was so many events that were getting congestion. And on real time, how can you explain that the DTMF tone arrived late? It's completely meaningless, so you rather discard it. The same thing appears on voice. If you are not bidirectional communication, you don't want latency. Otherwise, you cannot proceed with your communication, you cannot expose your ideas, you get lost in communication. You can notice on voice over IP that sometimes the latency is 1.5 seconds and you're like always talking on top of each other, like, oh, I'm sorry, oh no, you go first. It's something like that. But imagine that on 6 million events per hour, that's where we start having problems here. And it's not a big number. You're gonna see that that was just the beginning of the project. we had, for redundancy, two data centers. At that time was one in Dallas and one in Plymouth. And that was unpractical with Kafka. They don't have like a de facto solution for multi-DC to synchronize those events and to distribute and broadcast. You might end up using some tools to artificially inject onto the other data center, but together with congestions, once we have a pipe broken between Dallas and Plymouth and everything was down. So what can you do on those cases? And as I mentioned, it's real time. And that's the last point there. Event timestamp check. So, oh, there's a typo there. Out of timing on typing. So what happens, most of those events after a congestion, we had to check the timestamp because when evaluating that event or that command, if it was applicable, because if it was half a second or 1.5 seconds, it was not applicable anymore. So basically, every packet that we were receiving, first thing we were checking was a timestamp. We had to introduce that. Bit painful. So then we start thinking about changing that and how we would change it without impacting the system. As we saw, it's a nightmare picture. That's not even the full complete picture. So we thought about Snatch protocol hub, which is supposed to be lightweight, that unifies transport layers, so you can have REST, you can have RabbitMQ. In our case, we had Kafka at that time, but it has support RabbitMQ because it will be our next choice. It has to support, also Erlang message passing. But how would you do that on an extensible way and interchangeable way? Also for XMPP in some of the cases. We come up with Snatch. So this is a Erlang logo. This is from my hometown. I proudly present that logo. That's the original logo, by the way, so we can claim some rights. It's a candy factory from 1956. So just I wanted to put something there. So just saying, you know. We have the topology of Snatch. They told me not to come after here, so I'll try to stay on the picture. So Snatch is, we thought about body snatches, you know, like the worms and stuff, and then we have the claws. So how would we bring together in one body and you have multiple claws? That's how we call the adapters. So we had the initial adapter for WebSocket, one for XMPP and SIP, and then Kafka and RabbitMQ, which will be our next choice. So we could plug everything together, and since we saw on the previous picture, I will rewind a bit, but I know I'm not going to do that. I will just confuse you guys. But each of the components that we saw on the previous picture, you usually just saw one line there, but in fact, in reality, there was many lines, and a lot of those components were connected to multiple stuff. So every developer that arrived was like, I want to use this driver, I want to use this and you have multiple teams, even on multiple locations, so you end up with a development problem, a heavy lift supporting multiple protocols, so we came up with Snatch. Okay, let's standardize this so we also have the pluggable interface, and that's how you should plug other transports into our applications and components. Then obviously we made it already from open source. We were using open source drivers, connectors. On the XMPP one, we wanted to write it from scratch. I think it will be our third library for XMPP connection already in Erlang. But then we wrote yet another one, very lightweight. The code is only one single file, super simple. By the way, I encourage you to later on check a little bit on Snatch and check if you might want to use it for a new type of claw, like Broadway, for example, on Elixir. That would be a nice addition to it. Okay, so how would you do it? What would the path to glory there? We need to convert, try to unify XMPP and Kafka and RabbitMQ. So I read the book from the guy that wrote RabbitMQ, and there was some insights there also that reference to the XMPP model of routing. And it turns out that you can literally transpose the same routing rules that you have on XMPP also on RabbitMQ. And then we said, okay, why not? So we can just unify that transport, and that justify the development of Snatch, so we could actually code it. And we have the initial case, which was having like RabbitMQ routing XMPP traffic. based on the JIDs and the from and the to, just regular standard XMPP. That was brilliant. So RabbitMQ was great. You can see on the picture we were friends for some time, and then they also had federated queues, which allow like our multiple data centers communicate real time. Not many problems with congestions there. The federation, sometimes it took a while to reconnect and to transpose those events and to get them in sync, but it worked, let's say, reasonably well. We indeed have problems with filling queues, so the consumers not always are taking the things out of the queue fast enough, and then yeah, they kind of overflow. You can set up limits for that, but it just complicates things, and at the end we have the annoying checking message time. So everything that arrives I have to check, because that could be there for 1 hour, for 5 minutes, could be for 1 minute, and I'm interested on 200 milliseconds. So it's a big gap there. So we thought, okay, why not use XMPP as a bus? We were already using XMPP to connect the clients, even WebSockets, or it doesn't really matter, but we were already using it. Our clients had to communicate with our XMPP components anyway. So let's use XMPP as a bus. It turns out to be really, really fast. If you use presence and if you don't store, or if you disable message persistent or use IQs, for example, they will be transited, and if the destination is not there, it's simply not there. The message is like, boom, gone. You don't have to worry about message checking anymore. So that for us was a big win. Even CPU dropped drastically, so nobody had to do it. We didn't have problems with flipping DTMF. One use case that happens quite a lot in massive scale telco platforms. Unless, okay, if you use an event-based model, you might end up with that. If you use imperative and a single boxes hardware, but that's quite expensive nowadays. What happens, like, you know, when you dial and you need to type your credit card number or something like that, and sometimes it like doesn't get it, or if you use some of the cloud solutions, I won't name it, but you can see that that happens quite a lot. The digits flips and like invalid credit card or invalid keyword or invalid key code or whatever. Why? Usually they flip because on the message queue, depending on when it gets derailed, and the order there, the problem of the order there is not on the milliseconds, 100 milliseconds, it's more like a second later. One of the digits gets congested, and then it arrives there later, and then, yeah, we still see that on the RabbitMQ. So after we moved to XMPP, we didn't have that anymore. Like almost zero cases were like problems with input of DTMF or also input of voice activation detection, which is also something very, let's say, new, but sometimes we don't have an idea of how expensive it is, the voice detection or voice recognition during a phone call. Not only the CPU to detect the audio, but also to broadcast the event and broadcast to everybody that's interested on the event and then to react. So that's a lot of things that happens within a phone call on modern telcos. So we thought, okay, let's get one use case where we have this to justify thinking about XMPP UDP. So here, let's say that you have machine learning biometrics, which will detect, for example, in our case there, voice activation detection. So when somebody starts talking, we will receive an event because that might trigger something. And that has to be broadcasted because you have multiple agents or systems connected to it. You might have word spotting. I want to listen to this call. If they say bingo, I want to give them a prize. I don't know. If they input DTMF, so okay, what's your credit card number, sir? Can you input? Blah, blah, we want to recognize you. There's also humor detection, for example, for call centers, that we monitor the audio volume on the call. So if the audio threshold starts getting up and up and up and up and stays oscillating, we can also detect, let's say, shouting. So the humor detection was very, very, very much related with the volume of the call. So if you start on a volume and start increasing, you can like, okay, this call is getting very, very energetic. And the shout detection, obviously, when people start shouting, is very easy to detect programmatically. In that, on call centers, it was used to trigger the monitor or supervisor to eavesdrop the call to check if it was something wrong, if they could help the agent, or also check if it was not the agent shouting, of course. So let's talk about that then. Why we need that, and what's the use case, and where it's applicable, and try to dissect what would be the, let's say, ultimate solution for our problems. Because as I mentioned, 6 million in an hour. The problem is that we start having a million per minute. Then what happens? It was 10 times more events than we were expecting because it was a, let's say, a successful product. You have more users, but you also have more agents and more use cases and more people listening to it. So let's think about real time. So I'm trying also to tell you a story here. So we think I cannot solve you guys' problems, but perhaps you guys can share ideas on how to solve mine, and can spark some questions on how to solve yours as well. So real time, it's always like this. You have an extreme amount of events. You need low latency as possible. So we saw also yesterday a great talk about ad roll. They have to reply within a constraint on time. This is exactly the same ball game. You need to reply or react to those events within time. Otherwise, it's completely meaningless. Those events are volatile, which means that they are not persistent. They're just there to inform at that time. Otherwise, they don't matter anymore. And they're also ephemeral. Why? There is a slight difference between volatile and ephemeral. Volatile is when we don't store them, and ephemeral is like if they arrive a little bit late than they should, it's just meaningless. And usually the payload is reduced. Let's think a little bit on the scrubbing bytes. If you look at the voice codec transmission on RTP, you always send very small frames, even like 40 bytes or 20 milliseconds of audio, 40 milliseconds of audio with 140 bytes, 200 bytes. So we don't really need like per packet 2 kilobytes or 5 kilobytes. So just to think about it. So where do we need real time? Well, audio transmission bidirectional, as I mentioned. If I say one word, let's say ABC, and or let's go now, if the now arrives first and then let's go is not there, it's completely meaningless if it arrives 1 second or 2 seconds later. Imagine that you could scramble that on words. Video games as well. That's imagine that you are driving a car on a game, and then you do a curve, and then it takes like half a second, but you are on the game, you're already on the next curve, and then you just hit a tree. That's like doesn't mean anything if it's not delivered on time. And as I mentioned a lot, the DTMFs are really, really important. But also it's very important on boxing, by the way. Its own sport is really important. So if you see that the punch is coming to the left, and then you think about that 1 second later, you say, oh, I should go to the right. You might be taking the next punch because it's already too late, you know? So we remember the king. So we thought about, okay, it's now or never. That's the motto of the real time. We do it now or we just don't do it. Then we got the inspiration from Quick. This is a new protocol coming up. Still very experimental, but we got some inspiration. So you can actually establish without round trips the connection and don't have to use TCP, but still have some sort of reliability there. We didn't need that reliability, so we go for a very different mode of connecting to an XMPP server here. It's very simplistic, so it also it was inspired on the Jingle Nodes relay, so you can relay it. All the XMP traffic is interpreted as simple events or RTP packets, sort of, you know. Then the connection is pretty simple. You request on the main port. This is done in Elixir, so it will spawn a router there, allocates a new port for you, so it's dedicated. We don't have to do lookups for you. Give that port back and say, stream your events here and carry on. So no TCP negotiations required further. If you don't change the port or the combination on the IP, you don't even have to reconnect because it's connectionless. So that's also something to take into consideration. This is not recommended for client connection at all. This is for component to components, for internal bus on your platform that requires real time. So that's the objective there. To start with, that's what we're looking for now, that we have the UDP XMPP servers there. It's still in a binary phase. We still could not release it to public. It's still, we have some problems with ICMP as well. We want to detect if the other peer is not there to automatically remove the connection. And we didn't have that available on UDP socket on OTP 20 where we were using it. And that's it.
What do you use for software?
So on the software, most of the cases we use either HybriD or Mongoose IAM. Okay. Under the hood, they are more or less the same. And the process of XML is not the most expensive for us. The biggest problem that we are dealing here most of the time is intercomponent traffic. So right. I send a request to you and you send me back. If you think about the optimizations that you do on string parsing, you can win like 1 millisecond, half a millisecond and stuff like that, which is not relevant when you actually have to do network ping pongs and stuff like that, which brings you to 40, 50, to the hundreds of milliseconds problems. And that was the reason that we still don't have to optimize that much. And it was very simple to debug and cut corners as well. If you compare to SIP, for example, where you have to route headers and then you have to pass through all the hops again. It's right. Yeah, that was the reason.
Yeah. I was just thinking that maybe using something like protobuf instead of XML would have been better. But yeah, if you use like zlib compression on the wire, then probably it's not that bad as well.
Yeah, there is even on the UXMPP, just for curiosity, we don't even parse the XML. We just use the first element to route, and that's it. The rest is just we don't care.
Yes, I've done the same at some point. Thank you.
Thank you.